So we see x plus x is really just equal to x times parentheses 1 plus 1, which is just equal to 2x. Let's just remind ourselves this pattern that will continue. If we keep adding x's, we just get x plus x plus x. You pull all of these shared variables to the front, right? Be left with x times 1 plus 1 plus 1, or 3x. So it's easy. Now, where people really get tripped up here is the difference between addition of variables versus multiplication of variables. So let's take a look at multiplication. So if we're multiplying variables like x, we call the multiplication of variables typically exponent operations. So something like that. You might hear them talk about exponents, this is what they mean. So if you have x, just x, to the 0, that's an exponent. There's 0 in the exponent. What is this equal to? Now you may not have seen this yet, but this is a universal rule, basically. Any number to the 0 is just equal to 1. Easy, okay? This has to do with logarithms, which you probably haven't come across yet, but regardless, you get x then to the 1, let's say. What is that equal to? Well, x to the 1 is just equal to x, easy. What about x to the 2? Well, this is equal to x times x. X to the 3 is equal to x times x times x. Now, again, we could just leave it at this. We could just say, well, just remember that this is what it is. When this is this way, this is this way, okay? Well, it's a little deeper than that, so let's talk about why it is that this is the case. So, really what this draws upon is the multiplication rule for exponents. Okay, so the multiplication rule for exponents basically says that if you have some variable a, now a is the base, okay? So a to the some number n in the exponent times a, again, they need to share the same base in order to do this. A to the m, which is another number. So they could be the same number, m and n could equal each other, it doesn't matter, this applies, they could be different numbers. It just applies if you have two things being, two of the same base being multiplied together with exponents. So you have a to the n and a to the m. What's this actually equal to? Well, this is equal to a to the n plus m. Okay, so is that really what's happening here? Well, let's just break this apart. So each one of these x's actually is secretly hiding a 1 in their exponents. So this can be rewritten as x to the 1 times x to the 1. And if we follow this rule, here we have n is equal to 1, m is equal to 1. We get x to the 1 plus 1. And that equals x squared. Again, we can rewrite this as x to the 1 times x to the 1 times x to the 1. And this is equal to x to the 1 plus 1 plus 1, which is just equal to x cubed. Now this rule is universal. Again, like m and n don't have to equal each other. It just so happens that in these examples they do. So let's try this with a different example. Let's say you have x squared being multiplied by x cubed. What is that equal to? That is equal to x to the 2 plus 3, which is equal to x to the 5th. Easy. Very easy. All right, we're going to come back around to this when we talk about factoring in a minute.